I want to take charge of this exercise and take you through how you can work it out and relate it with what is in the notes. So allow me then to take some few minutes. I will tell the system for the sake of allowing me to compare the embedded answers with what I will get to display what you can see now. And because the main focus is the exercise, I will actually disable my video. So I do not think you have a problem in getting the mean of these 5 values. And if you have that challenge, then it means there is a serious problem. So you can confirm that the mean of 5 plus 5, I want to add 9 plus 11 plus 14. That one, the total is 44. So we can quickly say that sum of x is equal to 44, n is equal to 5. Therefore, x bar is equal to 44 divided by 5, which should be 8.8. That one you can see it is correct. Now, the variance, by definition, assuming this is the population, then such variance should be denoted by x. Okay, there's a clarification how to make. If this is a population, then this is not x bar. Sorry for that. Let me delete that. It's not x bar. It's not n. This is n, and this is mu. Sorry for that. Now, this will be sigma squared, and it will be just 1 over n as, okay, in an expanded form, it is better I write it like this: sum x squared over capital N minus sum x over capital N, this part squared. So the first part is I will square each value, then we get it here. So I will have 5 squared plus 5 squared plus 9 squared plus 11 squared plus 14 squared. That gives me 448 divided by 5 minus the other one. If you note, it is actually the mean 8.8 that we are squaring, and that gives me 448 divided by 5. Then I subtract 8.8 squared. That gives me 12.6. No, 12.16. And clearly you can see that is what is here. The mean was given here. So now that is about the population. We go to the sample now. We are told that if all possible samples of size 4 were taken from this data, what is the exact mean and the exact variance of their sample means? So you don't need to do it practically. This one, I expect you to use knowledge from the notes that we had, and I can go there and remind you that we said if you do sampling, then the sample means have a certain distribution. And the actual variance of the mean is actually a transformation of the original mean, and it will be this format. So we are saying sigma squared over n, then multiplied by n, capital N minus small n, divided by capital N minus small minus 1. But if n minus 1 and n, capital N minus small n, are large, if this value, especially the capital N, is large, then the entire formula reduces to this. If you get the square root, then you get the standard deviation of the mean, which we call the standard error. So this is the standard deviation. If you get the square root, you will get the standard deviation. So this is the knowledge we are supposed to apply here. So we go back then. Sorry. We are back here. I think I lost the competitions, but you already know what we mean. So we are saying the mean will just be the same. So the mean of the sample means will be mu. So it is similar to this. So that's why it is 8.8. But now the issue is here. The variance of the sample means will be equal to n minus n, n minus 1, then sigma squared over n. So sigma squared is the mean of the variance of the mean data here. So we now see our n was 5 minus 4, which is the sample size, then divided by 5 minus 1, then multiplied by 0.16 over n, which is 4. So we can now see that this becomes 12.16 times 1, because that will be 1, divided by 16. 0.16 divided by 16, that is 4 times 4, the denominator. So that will be 0.76. It is in line with what is given here. Now we go to the last question, which is talking about the sample size of 3 is taken from this data, the provided that the mean exceeds 10. Now here, we may estimate the variance of this new variable using this formula, but I have stated here that you use the usual estimate of standard error. Now, what we are being told is that we ignore this, so that we just use sigma over n as the variance, and therefore the standard deviation will be sigma over root n. This is the standard deviation of x bar, or now where n is 3. So with that, we are saying that probability that our mean x bar will exceed 10 should then be estimated by p set, or for this matter, let me start within the process, x minus mu, the mean of the sample means, and then sigma over root n, the standard deviation of x bar, must be bigger than 10. We subtract the mean, which is 8.8, the overall mean, divided by sigma over root n, or just put the square root to cover all, divide 0.16 over 3. So that is what we are supposed to compute. And now we are saying probability that this is a set the usual way, bigger than. Now we compute that quantity. So what do we get? So I'm using 10 minus 8.8. That will be 1.2. We are supposed to divide that by a square root. And here we have this other computation. 12.16 divided by 3. Yeah, so that part. So we can get the equal sign. So this would be 0.59. Actually, it is 96. So you can even say 0.6 instead of so we can just say 0.6. So when we go now to statistical tables, we realize that, as I have told you previously, that when you are reading the tables, it's how you do it. These are the set values. This central point is always 0. So we want to know where is 0.6. 0.6 is somewhere here ahead. So we are looking for this area on this end. And every time the area is less than 50%, 50% of the entire graph, I said always take 1 minus what you read from the table, which we call phi of 0.6. So we read from the table, then subtract 1. Now subtract the value from 1, and that is our answer. So I can write it on this side, if you don't mind. So this will be 1 minus, going to the statistical tables, 0.6. I'm looking for those tables. Where are they? Maybe here. I think I should have them somewhere. Yeah, they are here. Yeah, so I'll look for 0.6 and read this. This is the value, 0.7257. So I now move back here. This one is, but I have already cleared that, and that's sorry for that. So I'm saying 1 minus 0.72. What was the other value? Need to go back there. Check 7257. 7257. Why it is, yeah, 57. So this would be 0.2743. Yeah, this is what is given here. You can see that that question is not hard. Good. So allow me to stop there for now, so that I can work out the other one shortly.